So let's probably get the panel started. Thank you all the panel members for coming and also all the audience coming here today. We have a lot of good industry leaders here. Let's use that time to make some good advancements and we identify some of the next steps that we want to proceed as a OCP work group. Let me basically first introduce the team here. Let me just, I organized based on the company names, so it's kind of random. We are not probably sitting in the same order. We have, so instead of I'm going through their full bio, I'm just introduce based on what I know, so that's much easier here. And let's get started with the content. We have a Charge Kola here from Google, who's a senior software engineer. He's leading some of the modular design efforts within the Google. And before that, he was doing some of the chat content development and bringing it to the product. And we have Intel Mohan Kumar here from Intel Flow. He's leading, he's responsible for the cloud architecture efforts as well as sustaining efforts here. And he has long history of enabling a lot of industry standards. And also he has a lot more work, and also he is my manager.
I can make him say that.
And we have Phil Shafer from Juniper Networks. He has done a lot of amazing things in the network side, making all the YONG and all the different configs to reality. And we are glad to have here joining us into this group. And we have Panos from Meta. You had a big talk that he went over all the telemetry data sharing model. He's really like taking all the things make work, right? And he have done a lot of contribution to the Linux and also the Python and all the lot of open source activities. Glad to have you here. And we have Balint from Micron. He is responsible for the system memory architecture work. And also before Micron, he was with Intel leading some of the wonderful engineering architecture work. And before that, he was also led Sun as a VP and director over there. And Chukwunenye here is from Azure System Hardware, and he is responsible for all the end-to-end solutions over there on the hardware side. And we have Chango Chai from Samsung. He is responsible for SSD research and development efforts. And then probably let's get started on the panel discussion here. What I'm kind of looking for is a lot of audience contributions, discussions here. And I will start with some few questions. I would like to get started. And after that, I really want to see a lot of discussions here, right? So if you're really looking at that topic here, right, what we are doing as a group, we are trying to create cloud solutions that is not covered in current OCP projects. If you look at a hardware management project, it's covering a lot of BMC and all the hardware management related items. If you are looking at the OSF, they're covering some of the firmware related items. If you are looking at the security, they're covering a lot of security related items. So like that, I can go on, like a lot of each project has its own charters there, right? Here, what we are trying to do is the things that is going into the fleet or fleet management, you can think of that way, right? What we are missing out of the fleet on the per node or per system level, when you are putting together as a fleet, what are the missing areas that we want to address, and we want to bring a value value add to the whole cloud management. We want to bring it here. And as you saw, the couple of discussions, we have discussed about the telemetry data sharing model. We also discussed about complementing the BMC with the in-band management. And also we discussed about bringing redfish to the devices. One of the examples is the SSD. You know, like all what we want to do is we want to reuse existing the standards already defined. We want to extend it wherever it's possible. Whenever we make extensions, we want to give it back to that particular work group who is responsible for managing it, so that we can move on to solving next problems. That's what we are trying to focus here, right? So then basically, like my questions to the panel here, what is the big areas within the infrastructure that we are not really spend time doing research? And if you want to enable that kind of researches, what type of infrastructure that we need to create as a OCP so that people are engaged with a lot of rich data so that they can do a research and come back and improve on it. Maybe I will start with all of you. Maybe I'll start with Mohan and go from there.
Yeah. So I think having, working for Intel and shipping systems that get deployed in large scale in cloud data centers, one of the things is that, the kind of scale that you can test that and validate it at Intel compared to something that a cloud can do is an order of magnitude bigger, right? And there are some problems, interestingly, whether it's, silicon processor or memory or storage, that will show up only at scale, right? So it will be interesting to come up with the mechanism to collect that data and be able to analyze it to figure out what those problems are at scale. To me, so that's a problem at an industry level, at a company level. But at a forum like this, coming up with a standard for what data needs to be collected is the one thing that we can go address right now.
Okay. Thank you, Mohan. Go ahead, Chukwunenye.
So as Mohan was saying, right, collecting the data that's necessary, figuring out what those data sources need to be in order to determine how you would action upon the data. Different cloud vendors, so for instance, for Azure, we have, rich data set for our, fleet deployments. But we want to be able to leverage that data to look for failures, to look for ways of optimizing, the performance, minimizing our interruptible rates, right? So our error numbers. So the data is, for the most part, the anchor to what we're trying to do with the cloud service model. And how we position, package that data, I'll let some of our other work group members speak to that, but that's part and parcel to what we need to do to get to where we would like to get to.
I'm coming from a slightly different perspective here, and what I see that computer architectures are getting more and more complex. Think about CXL as one example. The number of companies are talking about memory pooling, and suddenly the relationship between a device and a server is going to be much more complicated. And so root causing the problem and associating the failure modes, with some environmental or some events, which led to the failure is going to be more complex. So this is terrific, what's happening, but how do we start working on a more complex system architectures, and how do we derive meaningful, actionable information? That would be very critical.
Thank you. Bill?
So I'm new to OCP, but my interest is in finding ways to make, on the networking side, we have our own history and our own way of doing things, and that's not always conducive to the data center, and trying to find ways to change and marry what we have to make it more conducive and more streamlined so it fits in better with the data centers would be my focus.
Okay, Panos? Yeah, there's
a mic. Okay, So I was thinking about like these synergies. Like some of us may already have rich data sets, or even like have a few fragmented data sets from the network perspective to the device perspective or server perspective. How do we bring all that together and even across the hyperscalers, across us operators, to discover new patterns in the devices? Let's say allow the vendor to look at the failure rates of their drives under different conditions, all these things, and be comfortable doing it. Because of course, much of that is data that has like some competitive value to us having it. So we need to find that sweet spot where this data can be analyzed by third parties or can be pivoted to a different axis so that we can perform an extra analysis, an extra correlation, and get more value out of it, as Sanguini said, to drive our error rates down and help the development of more resilient hardware.
Yeah, plus one to what Panos said, it's like a lot of the cloud providers have rich data sets that the like hardware vendors themselves do not have. It's basically the scale of it, right? Feeding the data back at the same time protecting our like proprietary stuff, similar to what like Panos talk mentioned, right? There are certain things that we consider proprietary, like how we lay out a network, certain things we don't want to leak, but other things about the devices we want to share. The net result is that we can actually end up making devices that are like a lot more fault tolerant, right? Which lesser failure rates. Other thing we care about is that we have like a very short window of time to like do a reboot or a fix. How can we basically like do a better fault prediction and better overall system so that during the downtime window we can reduce the downtime window or combine the different downtime windows into a single downtime window? And that'll be like another interesting thing to like figure out.
Okay, I'm from Samsung. So from device point of view, first it would be great if we could make a kind of a unified way to collect the data and also unify the metrics we could collect for upper layer analysis. I wanted to reiterate our panel's thought also. We definitely need some effective fault prediction mechanism in addition to some infrastructure collect data effectively. So our telemetry work and embedded management is a starting point, but we needed to extend it and make a unified infrastructure that could be applied for multiple different components. So in summary, not only collecting data, but also infrastructure and some analysis layer should be addressed.
So let me probably summarize it here, right? I think what I'm hearing is, like Balint said, right? When you're getting new technologies, you want to make sure that you have enough good infrastructure in place so that you can get those things ready and go and analyze and fix the problems first. And there are already existing technologies where still need help, where it's most of the things really need a lot more telemetries and a lot more analyzing tools. You need to have a mechanism to share the data so that easily you can enable the research work. If you don't share the data, you won't really get that much details into the research. Is there anybody else you want to add anything to the summary? Go ahead.
One more thing I wanted to add. We may already have the data. We may already have enough data to work and do even more analysis that we are doing today. So every bit of data in a Shannon way counts, but every bit of data also costs. So the point is to collect it in such a way that we can take the full potential out of this data that we may have or may be collecting in one way or another, or even be able to correlate it in new ways that we have not thought of. And the hardware, our patents, our data centers are moving very, very fast, and we need to stay ahead of the game and have enough mechanisms or enough data to correlate for patterns that we have not designed our systems for yet.
Yeah, I think just about kind of reiterate, right? We have enough data, but are we able to share the data and get that research
We
going
need to
on,
fix
right?
that.
Right. So for that, you do need some kind of clear model or mechanisms in place so that people can feel safe in sharing that data, right? Yeah, go ahead. You want to say something? Yeah. So anybody else from audience, you want to jump in, add any questions or add additional comment?
This question is primarily, I guess, for Cheng Ho and Balint. My name is Joel Diedrich. I'm with Kyoksha, so full disclosure, you know, the three of us are arch competitors. We're trying to kill each other, but we're also trying to cooperate. And one of the problems I think we face is that we can't possibly collect the amount of data that Chukwunenye or Panos can collect, but yet the data that's most valuable is proprietary, is something that we would never reveal to each other. So does it make sense to try to create a data collection infrastructure that allows the data to be opaque, to feed it back to the vendor in a way that doesn't disclose their, you know, super secret sauce to their competitors, but allows them to make their product more successful for the customer?
Good.
I think I have a few answers to that. First of all, yeah, it doesn't mean if we share the data, we may not share it with everybody, not the same data. So one of the ideas is to share only numbers to that vendor whose devices are affected. So you will not hear of your competitors' numbers. The other idea is we don't like, we aggregate it in a way that their own numbers are not ever revealed. Rather, we can only reveal some rates of errors and like relative numbers that will still not allow the vendor or their competitors to have that kind of data that we classify as proprietary. And,
I'm proposing something even more paranoid.
Yeah.
I'm saying that we may each have data that is unique to our architecture even, may not make any sense to our competitors, and which we may not even be willing to reveal to our customers. May not even be willing to allow our customers to see it.
There is a catch there. There is a catch there. And the catch is that we would not, like us as operators, as owners of the data center, we would not allow our systems to export data that we cannot understand what they mean. So there is a strict requirement that we only share what data we can understand. If you talk to us about like a vendor-specific counter, a register that we don't understand and ask us to share that and let it get out of the data center, we will most probably refuse that.
Right. I think that's been everyone's experience.
Yeah. I think adding to that, right? There's a risk involved, right? If you want an opaque blob to be exported, how can we, as operators, ensure that there is no PII going out?
That's the perfect question, and I think it's a question for this group to try to think about, to apply our creativity to figuring out how can we export data that will help us all in the end, but which is so sensitive that we manufacturers may not be willing to expose it even to our customers. I don't have an answer to that, but I propose it as a worthy problem.
Yeah, I think we kind of.
I'll bring an answer that I had given to a very different problem, and that one of the ideas, if you want not to expose data, so you have a system that contains very sensitive data, you want to do an analysis on that by an external vendor which has their very proprietary algorithm would be to build an enclosure without our premises, like a VM, that can run your analysis and gets very, very raw numbers in a way that like the bits won't add up and would not contain anything critical, and run that inside our premises as a black box analyzer in a contained environment, something like that, and not give you the data. That's one method of doing that, I suppose. Yes.
There's one point I would like to add, that I completely agree with you about this vendor-specific information, which is highly proprietary. But I want to highlight, that this is not only memory related. I would argue that it's related to any piece of silicon deployed in a data center. They have, kind of vendor-specific areas which is not shared or disclosed because it's related to manufacturing yield information you can derive from it, or some other highly proprietary information. So this is not just a memory problem.
Yeah, I totally agree with Balint. And one thing we may consider is that we could provide some readable code or some readable things that can be analyzed inside the device or inside our customer infrastructure. And then we could collect only output or some result instead of retrieve all the information. That could be one potential way we could consider.
Analysis code is open.
Yes,
Good.
yes.
Okay. Yeah, go ahead, Drew.
I'd like to add something. So we've looked at a lot of data with vendors, just like you're describing, and I understand the need to keep things closed, but what I found is that when we collaborate with a vendor, we get a lot better results. So I would also, I understand that, and we have looked at some extremely sensitive data from vendors. We've earned their trust, and we've found new failure modes that they weren't aware of. So I'd also say there's really a value to building a partnership.
Right.
Yeah,
Thank
I
you.
totally agree with you, yeah.
I also agree with that, and the only comment to add there, those are per situation, or opportunities. And I think the team is working on some automated way of collecting information at the data center scale and exporting it. So I think maybe there needs to be a dual approach. One of them is to provide this kind of not, the granularity might be easier or deeper, if you have the ability to have that collaboration with the vendor and the user.
Go ahead, and
Maybe I can add something here. So in the context of this problem thing was raised, if the data that we're collecting is so proprietary that it'll be hard to share, I think the way we want to look at it is what problem we are solving here. The problem we are trying to solve is there are some failures happening at scale, and we have two choices. Either we take the components, ship it back to the vendor because we don't understand the failure, or provide some data that we can understand ourselves with the help of vendor and debug that, and then send only the component that really are failing, not everything that just fails. So as long as we are kind of looking into what problem we are solving, I think this the issue that was raised can be addressed based on that use case.
okay. Thank you, Anil. Let us probably move on to a couple of other areas. So again, if you have any particular question, you can bring it up here. Another question that I have is,
Sammy?
yeah, good.
Oh, sorry. I couldn't help thinking as we're talking about this, that there may be an opportunity inside of OCP to take in this data from hyperscalers and take it in a way that, take it and store it, quite frankly, in a way that the vendors can use and maybe we can agree on some metrics and so forth that are not highly proprietary, but still add value and add that scale that the vendors don't have in their own manufacturing pipelines and so forth, but only comes from the big hyperscalers. And I'm wondering if that kind of thing is in scope or has already been discussed in some of this.
Yeah, I think there's a couple of things, right? We were having this, the telemetry data sharing model, we were having a lot of discussions there. So there is a lot of anonymizing the data, as well as you need to have, I think even Ru brought up, depending on the situation, you need to have a lot more data to be collected, focusing on that particular areas, right? So there is a lot of discussions there, but we, as a kind of industry or OCP, we need to agree, here is a minimum requirement for what type of data need to be available so that you can collect and at least log and share so that you can do a lot more research or debug those problems, right? I think let's probably move on to the next one. I think we are almost out of time. Maybe I think I will ask each one, what is in your top of mind? Maybe there's already existing things there. We need to do some additional enhancement within the industry so that we can able to be better in certain areas. Maybe, for example, memory errors always popping up, right? Similar to that, you might have some other things popping up. What do you think? Maybe give a 30-second view of each one. What do you want to see industry to focus on? At least cloud services models and the infrastructure management need to focus on so that we can get the synergy going. Go ahead, Mohan.
Okay. So I'm going to, given us 30 seconds, I'm going to give you guys 2 quick anecdotes which kind of tie in with all the questions that were asked. We were debugging a problem with respect to errors that were happening in the field from a given customer. And we struggled with why only that person's data was a problem until we finally realized that the thing was sitting in Denver. And that key piece of information changed everything because there was an unprotected circuit, and that was basically taking errors. Because Denver, as you know, is a mile-high city, so there was a lot more radiation-related issues going on there. Similarly, there was one time there was a university deployment, and in the university deployment, only one rack was having memory errors. Every other rack was fine. And we had no idea what was going on, what was so special about that rack, until we figured out that there was a failing PDU. It was not completely failing, it was just flaking out on the voltage. And it was inducing memory errors. No amount of you giving me this is a single bit error, giving me the address would have really helped me sit to the bottom of it. So really what we need is, we need to define profiles in this OCP, right? We need to say memory profile, and the memory profile is not you telling me the memory error is in your daemon location. Maybe that's not going to help Balint solve this problem. You need to say the additional ambient information. What is the altitude? What is the temperature it was operating at, right? There is a lot of other
environment
information.
data
Right.
need to be there.
So you need to take it upon this group to essentially define profiles for what does a memory error profile look like? What does a CPU error profile look like? What is a storage error profile? And then we can go to what the gentleman last asked the question, to go collect that information and maybe be the repository where we keep that information.
Okay, thank you, Mohan.
So I think just leveraging from the volume of data we have and knowing that a lot of the problems manifest at scale more so than we see in smaller infrastructure. Certainly, there's efforts to go down the path of doing some data learning in order to understand. So we have, volumes of data, and we want to be able to do some predictive analysis of where some of the failures may come up, right? We're seeing a lot of, diversity in the types of systems we're building based on the usage model. So you can think, across GPU type architectures, you can think across specialty compute, and you start to see that some of the failing mechanisms, even though they have similar class devices at the component level, tend to differ slightly, right? And in some cases, there's some dependencies on what workloads are being run, right? So you can think general purpose compute versus GPU architectures. So what I'd really like to see is a lot more synergy around, data learning in that respect in order to understand some of these failures and potential failure mechanisms from when they happen and to what sensitivity to the system architecture that they show up as.
Thank you, Chukwunenye.
Well, you basically cleared the point I wanted to make, but it's a very serious issue, that a component, in one system environment is working and it doesn't work in other system environment, and those are kind of the hardest problem to capture and debug. But I want to point out to another trivial comment, that we have a shared interest here. I think both the users and the manufacturers of the devices are equally interested to understand the failures, analyze the failure modes, and then find some corrective action. So I don't think it's a conflicting situation. It's something which we are all interested in industry to continue improve the quality and help the customers, to run more reliable data centers. And so I think the effort you guys are doing is very, very valuable.
Okay. Thank you, Balint. Go ahead, Phil.
I'd also echo the volume of data and the way that data is processed. To me, the interesting thing is the way you model that data, because you're trying to coalesce similar data together, but you also want to preserve the uniqueness of each type of device, because there's so much proprietary information that you want to be able to carry, but trying to do both, to abstract the model and still keep the specifics of the environment of the machine or the driver, whatever that you're actually caring about.
Okay, thank you, Phil. Go ahead, Panos.
Yes, I'm thinking now about the value that the open source model has brought, like from the software now to the hardware, which is OCP itself, and now we want to extend this same value to the way we treat our hardware and analyze it at scale. And rather than have some proprietary barriers to how the vendors think that the hardware would be used, and then what we think as operators of how do we monitor that, break these barriers and come to an agreement, to a common model that we feed from both ways, and we have a common understanding of what we need to do the collection, the analysis, and failure prediction, perhaps, of the hardware we run.
Okay. Thank you.
Yeah, I would, plus one to what Panos mentioned. So in addition to just even collecting the current telemetry, we normally collect a time series of the telemetry over all time, right, at a certain frequency. And that provides a lot of value. But I think similar to what Mohan mentioned, you may have to annotate it, right? Altitude as an example, temperature sensor is another thing. Similarly, the voltage regulator values, right? So there are additional information we collect, but having a profile that actually explains why they need the additional information is also helpful, right? We wouldn't feel very comfortable sharing additional data if we don't think it's needed, right? Standardizing on that, it's a plus one. Other thing is that I would also challenge the hardware vendors to figure out can you reduce your proprietary stuff, right? If you look back at it like a long time ago, most of the metrics were proprietary. Now it's all standardized, right? Pushing more towards standard is better. You may not want to leak it to the public or to another vendor, but making it available in a way that hyperscalers can actually collect those metrics and persist them, so that it's useful for you to debug it later on or figure out what's happening, right? But at the same time, we also don't want fully opaque metrics, certain sort of counters which have so that we can at least reasonably understand them would be okay, but totally opaque may not really work for us, right? So figure out a way to collaborate to make this thing work so that we can all drive everything in the industry forward would be great.
Thank you. George, go ahead, Chandraji.
Okay, so I think first, from a research point of view, I think I'd like to see some kind of a fault prediction scheme and do analysis and estimate the life of components or devices. I think from CSM, our group point of view, we could work on some kind of unified infrastructure or some method to do lifetime management scheme. If we combine the fault prediction stuff, then I think we could more effectively do lifetime management of components and systems. So if we work together and leverage each other, then I think we could make a good synergy together.
Okay, thank you. Thank you for panel joining, and thank you all of you joining us. I hope we are able to get a lot of data out of the wonderful people here. Thank you very much.
Thank you, Sammy.